This is the next question. We need a figure. So let me draw the circle. So this point is G. This is 114 degrees. And this angle is given as 18 degrees. So there is a tangent at A, tangent at D. Okay, now figure is not to scale. This point is E. Okay, I'm going to take this point as E. So let me take this point as E, and then I will just say answer the following questions. Okay, now we will have to get ACD. Okay, this angle is required. Now you see this chord AD, this creates an angle at the center, and the same chord creates an angle at the circumference. So I'm going to use this theorem. Angle subtended by the chord at the center will be twice the angle subtended by the same chord with the circumference. So what is the meaning? It means angle AOD will be equal to twice ACD, where AD is the chord that subtends the angle. Okay, so AOD is given as 140. This is equal to twice the angle subtended at the circumference. Apparently we do not have this, but what we can do is we can rewrite ACD as 114 divided by 2, which will give us 57 degrees. So therefore ACD is 57 degrees. Okay, that's the solution for this question. And next we need AED. Okay, we need this angle. Now you observe the diagram. OD is the radii or radius that is making an angle with D. Okay, but what is D? But D is the point of tangency of the line EG, right? EG is striking the circle at D. EG. So by tangent theorem, the radius will always make an angle of 90 degree with the tangent. Okay, so by this theorem there is a 90 degree hit here, and by the same theorem there is a 90 degree hit here. So we need E, but O, or I would say AODE is a quadrilateral. We observe that AODE is a quadrilateral. So this means angle at A plus angle at O plus angle at D plus angle at E is 360 degrees. So this means angle at A is 90, angle at D is 90, angle at O is 114, angle at E is what is required. So I add 90 plus 90, 180 plus 114, 49294. Therefore angle E is 360 minus 294. So what is that? From 360 you subtract 294, 10, 6, and then you have 5 there. That's going to give you 6 there, right? 10, 1. Okay, so 66 degrees. Angle at E is 66 degrees. So that's a solution for AED. So therefore AED is 66 degrees. Okay, next we need OAC. Okay, we need OAC, we need this angle. Okay, so this is going to be a little bit tricky. Now what I wish to do is, from O I'm going to stretch a line to meet at C. So now clearly OC, probably let me okay, now OC is a radii, and clearly if we were to consider triangle ODC, OC is equal to OD. This means triangle ODC is isosceles. So this means this side and this side are one and the same. Now we know this entire angle is 90 degrees. So from 90 degree, if I take away 18 degrees, this is 18 degrees. I'm going to take away 18 degrees. So I get 10 to 8. From 8 I take away 1, I get 72 degrees. Okay, so this angle is 72 degrees. Now this entire thing is isosceles, right? So that would mean this base angle, this is also going to be 72 degrees. So sum of the triangles, so using the sum of triangles, or I would say sum of the angles in triangle being equal to 180 degrees, we have, because I'm interested in this angle at O, I only know this angle 114, but we don't need that. So we have angle at O to be equal to, from 180 I subtract 2 times of 72. So from 180, 2 2s are 4, 7 times 2 is 14. Take away 4, you get 6. From 7 you take away 4, you get 36 degrees. So angle at O is 36 degrees. Why do we need this? So this angle is 36 degrees. Watch out. Now what I'm going to do is I'm going to consider OAC, this entire triangle. Consider OAC. Now angle at O, total angle at O is 114 degree plus 36. So what is that? This is 10, 1, 150. So 10, 1, 150. If this is 150, this entire angle is 150. The remaining 30 angle, this should be 15, this should be 15. Is it not? Since triangle OAC is isosceles. Why do I say isosceles? You see here, this is a radii, this is also a radii. So this means the base angle should be same. Base angle should be same. So this means angle at A should be equal to the angle at C, which is equal to 15 degrees. So therefore OAC, angle at OAC is equal to 15 degrees. This is what is required. Okay, so let me go to the figure. You see, this angle is what is required. So this is going to be 15 degrees. Now there is the last part. We need to get the angle ABC. So we need to get this angle. Okay. Now for that, what I wish to do foremost is to consider triangle AOD. Okay, I know this angle is given to be as 114. Right, this angle is given as 114, but we consider triangle AOD. Now since OA is equal to OD, this means triangle AOD is an isosceles. So this means the base angle is same. Base angle is same. So this means angle at A is equal to angle at D. But angle at O is 114 degrees. So this means 114 degree positive angle at A plus angle at D is 180 degree from the law of triangles. But angle at A is equal to angle at D. So this means 114 degree plus angle at A plus angle at A is equal to 180 degrees. Which means 2 times angle A is equal to 180 minus 114. So from 180 you take 114 out. 10, 6, 7. From 7 you take away 1, you get 66. So 2 times angle A is 66. So angle at A is 66 over 2. So angle at A is 33 degrees. So this means this angle at A is 33 degrees, means angle at D, this angle is also going to be 33 degrees. Now we want to get this entire stretch. Okay, this entire stretch is required. So that means, okay, consider, or I would say that clearly, see, BADC is a cyclic quadrilateral. Clearly BADC is cyclic quadrilateral. So this in turn means angle B plus angle D. The law is, let me state the law, the opposite angles of cyclic quadrilaterals are supplementary. So that means angle B plus angle D is equal to 180 degrees. But what is angle D? See, this is 33 and this is 72. So angle D is 33 plus 72. What do you get here? 5 and 10, 105. 105 degrees. So since angle D is 105 degrees, therefore angle B is 180 minus 105. So what do you get? From 180 you take away 105. That's going to be 75 degrees. So this is the angle value for angle B. So this in turn means angle ABC is 75 degrees.